So let's recall what we did in the previous lecture. In the previous lecture, we have talked regarding the Erdos and Reid model, and which is denoted as GNP graph model, where n denotes the number of vertices and p denotes the probability of having the edges. Then we have seen what is the expected number of edges in the GNP graph model, and it will come turns out that it is n into n minus 1 by 2 into p is the expected number of edges in the GNP graph model. Then we have seen another graph model that is known as GNM model, which contains n number of nodes or vertices and m number of edges. So there are many graphs of having n number of nodes and m number of edges are possible. Among them, you have to choose any one, and that's why it is a random graph. Then we have talked about the degree distribution. That means what will be the probability of the vertex having the degree d. And it turns out that if the vertex, the probability that the vertex v has a degree d is NCD, p power d1 minus p power n minus d, that is the binomial distribution that we have. Then we have talked regarding the expected number of degree distribution, and we have or expected mean of a degree, and that turns out to be NP, that we have derived that formula. And then I'll give you as a homework that what will be the variance of the degree distribution, and it will be the NP into 1 minus P, that you have to derive by yourself. Then in the GN 1 by 2 model, that means the probability is 0.2, then the degree is close to n by 2. Degree of each vertex will be close to n by 2. That we have proved into the example. And then we have seen what you mean by degree distribution. So we have constructed some graph, and then we have seen the what is the degree distribution in that, and we have seen that degree distribution is follow a power law distribution, and the power law distribution is behave, or the formula for power law distribution is this. And then we have seen this result, which tells you that the degree of vertex v and expected value, that is NP, is up beyond this values, its probability will goes to 0. And it's saying that this theorem is saying that the degree of any vertex v in the GNP graph model, it's between this range. In this lecture, we are going to discuss regarding the existence of triangle in GNP graph model. Basically, we are considering the value of p here, it is d by n. So in this GNP graph model, that is n is the number of vertices and p is the probability, which is we consider as d by n, where d is some constant. Then the question one can ask here, what is the expected number of triangle in G and d by n when d is constant? So can somebody give me this answer? What do you think? If I increase the value of n, that means if I increase the number of vertices into GNP graph model, what should happen to the triangle? It will be increased, or what should happen? What is your logic says or intuition says? So you understand the first of all the question. The question is you have given a GNP graph model and the probability is d by n. For example, if I start with 1000 vertices, that means the probability is 1 d by 1000. So d is some value. Let me take d is 1. So it is 1 by 1000 is the probability. Okay. That means having the age between any two edges, there is a 1000 probability will be there. Now, if I increase the number of values of n, then what should happen to triangle? Will it be increased? Triangle means a figure like this should be there. Okay, so there are 1000 vertices. Yes.
So decreased maybe.
Decrease. So yeah, you are right. So it should be decreased. Okay, so the number of vertices increase. One might expect the number of triangle is increased, but this is not the case. Probability of age between two vertices actually decreased by n here. And as the number of vertices increase, one might expect that the number of triangles is to be increased. But this is not the case. All through the number of triangles of the vertices goes to n cube. And the probability of edge between two specific vertices decrease by linearly with n. Thus, the probability of all these three edges between pair of vertices in the triangle being present goes to n raised to minus 3. That means all these three vertices being present. That means what is the probability of presenting this edges? It is 1 by n or it is d by n. Here present of this edges will be d by n and presence of this edges is also be d by n. So the existence of all these three edges will be present will be d cube by n cube. This will be the probability. That means it is n raised to minus 3 is the probability that we have. And exactly it's cancelling the rate of growth of triangle. Okay, so let us see this situation into this GNP graph model. So the expected number of triangles that is independent of n. This is actually we are going to prove. The expectation is approximately d cube by 6. This is our objective. So we have a n number of triangles, sorry, n number of vertices, and out of this, if I have this triangle, then how many ways I can choose this three vertices? So out of n vertices,
NC3.
NC3. So there are NC3 triples of triangle or triangle vertices. Okay. So this many ways we can choose our three vertices. And each vertices have a probability and each vertices. So as I have talked here in the previous slide, that means what will be the probability having each edges? It is d cube by n cube that we have discussed. That means having one edge is a probability is d by n. The second is also having the probability is d by n, and third one is also having the probability d by n. So all these three edges having the probability is d cube by n cube. So that means this is the vertices. Each triplet, each of this triplet has probability it is d by n cube of being a triangle. So that will be the triangle we have. Let us consider that indicates the variable, that one variable we need to fix. Let dij. That means I am fixing this I, j and k are the vertices. So I'm just making this as a notation. That is delta ijk be the indicator variable. For triangle with vertices I, j and k. So this delta ijk is a variable. It's indicate that this vertices I, j and k having a triangle. That means this edges will be present, this edge is present, and this edge is also present in that. So that is, what does it mean of this things is all the three edges, that is ij, jk and ki being present. Then if I want to count the number of edges, sorry, the number of triangles in the that GNP graph model, that I will denote it by x. So the number of triangle, let's say it is equal to x. Then what should be the value of x in terms of this delta ij? That means I need to count how many of this type of delta is there. That means it is a summation of delta ijk, where the summation is taken over I, j and k. That means if ijk is the one triangle, and there is another vertices which having the triangle, another one. So each triangle we need to count, and our objective is to find out the what will be the expectation of this x. That is our objective. And even through the existence of triangles are not statistically independent, even by linearity of expectation, which does not assume that independence of the variable. The expected value of the random variable is the sum of the expected value. That means if I want to calculate the E of x, that is our objective, is to find out what is the expectation of x, that is equal to the expectation of this summation ijk delta ij, and that's saying that it is summation of delta ij, that is sum of the expectation of delta ij. But what will be the expectation of delta ijk? As I told you that the probability of choosing 3 vertices out of n vertices is NC3, and presenting all the 3 edges having the probability is d by n cube. So that's why it is NC3 into d by n whole cube. And if you can write down this NC3 as n into n minus 1 into n minus 2 by 6, that is the value of NC3, into d cube by n cube, and you just, for n large, that means if n is tending to infinity, that will be n cube by 6. We'll write n divided by n will gives me 1, 1 minus 1 by n, and this will gives me 1 minus 2 by n. So as n large, that means this will tends to d cube by 6 as n tends to infinity. So if you increase the value of n, then the expected value will be d cube by 6. That means the number of triangle will be fixed. It will not depends on n. It should be fixed. Even through the average, there are d cube by 6 number of triangle per graph, and does not mean that the high probability of the graph has triangles. That means if you increase the value of n, it does not mean the when n is increased, the number of triangles are increase or decrease. It should be expected that it should be this value, that is a constant. So if I can have d is equal to 1, then it will be 1 by 6 fixed triangle you always have into the GNP graph. That is the conclusion we make out of this. So let me write that. So therefore, even though on an average there are d cube by 6 triangle per graph. This does not mean that the high probability of a graph has a triangle. This does not mean that. With high probability, a graph has a triangle. Okay, so it does not mean. It may be half of the graph have d cube by 3 triangles, and other half of the have the average d cube by 6 triangles. Then the probability is 1 by 2, and the graph is selected at the random could have no triangles. It may possible. If 1 by n of a graph had d cube by 6 into n triangles, and the remaining graph had no triangles, then n goes to infinity, the probability that the selected random could have the triangle goes to 0. And to see this, we need to understand what does it mean of the, so what is our objective is to prove that the probability of x is equal to 0. What is x? We have already defined. X is the number of triangle in the graph. So if the probability of x is equal to 0 is has it's non-zero, or I can say it is will be tends to 0. If I can prove that one, so for that we need to see the second moment, And to calculate, or I can say second monument argument, where the small fraction of the graph have a large number of triangle and remaining graph have none. So for that we need to calculate what will be the variance of this x. So as we know that the variance formula is defined as e of x square minus e x whole square. So I need to calculate what is e of x square. E x square, it is easy to calculate because ex we already have. The question is to calculate what will be the value of this one. That is expectation of x square. X square is nothing but the triangle square. So now there are 6 vertices together. It may be 6 or there are different situations we need to looking out. So now let us calculate e of x square, where x is number of triangle. We already write that what will be the value of x. X is summation of delta ijk, and this summation is running over delta ij, where this delta ijk is an indicator variable of triangle with vertices ij and k being present. So I need to calculate what is the expectation of this one. That means e of x square. That means it is e of summation of delta ij, sorry, the summation of ijk delta ijk square. So if I can write down this square is actually written as e of summation ijk delta ijk. This is product with summation I dash z dash k dash delta I dash z dash and k dash. So actually that will be the product of two. This type of summation is there. Now that means what we have given. We have given us 6 vertices, and what is the probability of having this 6 vertices or less than that is triangle. So first of all, the case number 1, it's saying that these 6 vertices are different. That means they form 2 triangles together. So this is the case number 1 we have. In case 2, it may happen that there are 2 triangles, but that 2 triangle is having this situation. This is case number 2. The case number 3, it may have that the triangle is of this type in the graph. And in the case 4, you have 2 identical. That means all these 3 vertices are same. So I can say this is I is same as I dash. So there will be 2 identical triangle is there. So like this. So it's for showing the figure I have just drawn like this. actually they are the two triangles has been drawn. So there will be two triangles with the same vertices. Just see that. Okay. It is two color, that's why I floated two colors. So there will be this summation contains all these four cases because there are two delta ij k is there. So there are total six number of vertices are there, and among the six number of vertices, it may contains any one of these three cases. It may have there's two different triangle. It may have one common vertex in that. It may have two common vertex. It may have three common vertex. Is there any other cases left? Here no common vertex. Here one common vertex. Here two common vertex. Here all the three common vertexes there. So this four cases is there. I will say this is S1. The whatever the vertices which satisfy this situation, it is S1. For this two, it is S2. For this one, it is S3. For this one, it is S4. So let's say it is denoted as this name. Now in case 1, let S1 be the set of ijk and I dash, j dash and k dash which share. So I'll consider both this situation together because it will have same calculation for both this situation. S1, I will say for this case, it is both this case has S1 situation. So S1 will be the set of all this ijk and I dash, j dash, k dash which share at most one vertex. At most one vertex means there is no vertex is common or at least one vertex. That means one vertex is there. So hence the two triangle share no edges. So there will be no edges common in between this. Here there is one edge. Here there is three edges. So in this case, what we can say about delta ijk, this triangle by choosing this triangle's edges and this triangle edges will be the different or will be the same, or it will be depends on first triangle. Let me say this is first triangle, this is the second triangle. If I have choose this triangle, this edges, that means I have choose this edge and this edge, the probability we have, it will be depends on choosing this edges or it will be different. What is your opinion regarding this? So what I'm
Sir,
saying is delta, yes,
can you repeat your question?
if I have choose this edges, three edges for triangle 1, and then I will choose the three edges of the triangle 2, will be depends on the first situation or not?
Not.
Not
No,
dependent.
sir.
Here in the case 2 also it is not dependent, because if I take this three triangles, this three edges and this three edges, it will be totally different, or it is a independent events choosing an edge. But this, if I take this one, then it will not, because the one edge is common in that. So that's why I'm saying that delta ij and delta I dash, j dash, k dash are independent. in this for S1. For in S1 it is independent. So therefore, what I can say about this expectation of delta ijk, delta I dash j dash k dash over S1, that means whatever the I dash j dash k dash and ijk, all of them are in S1, it is an independent event. So I can take this, and we know that the expectation of x plus y is equal to expectation of x plus expectation of y if x and y are independent events. So that's why we can write down this is equal to summation of s1, sorry, this is we can write down, and also expectation of x into y is expectation of x into y. In that we need the independence, in this we don't require the independence. So using this, we'll write this is expectation of delta I dash j dash, sorry, I dash I j k into expectation of I dash j dash k dash. This we can write. And this I can write down, this is less than or equal to summation of S1, not S1, but I can take all ijk into expectation of delta ijk into summation of all ijk expectation of delta I dash j dash k dash. Here is also I dash j dash k dash. So this is the things we got. See, this expectation is we already have the formula for that. We already have this. Okay, so this is e of x, this is e of x. So that will be, this is e of x, and this is also e of x. So that is e of x square for this case. Okay. So that means for case number 1, that is case 1 and 2, we have this situation. For case 3 and 4, I will take this is both this case combined and we'll say it is S2. So in the S2, actually, they have shared two vertices and hence one edge. No, that should be different. So that has to be different. So we need to have three parts here. So this
Sir,
is
at least one vertex common करके नहीं कर सकते.
But in that, both the situation is at least one vertex common. But नहीं कर सकते because the situation is different. Because in this is not independent event. So I cannot now split. I cannot use this situation. So all these three situation is different. So here I'm just saying it is S2. That is case number 2, where S2 is share two common vertices and hence one edge. So if I can choose this one edge, it will be dependent event now. It is not independent event. So case number 2, let S2 be the set of vertices I, j, k and I dash, j dash, k dash share two vertices and hence one common edge. So for that, you just see the figure, this figure case 3. Now, how many vertices are there and how many edges are there in the case 3? So there are 1, 2, 3, 4 vertices and 5 edges involved. So we note that there are 4 vertices and 5 edges are involved all over. So how many ways we can, so there are at most NC4 because there are 4 vertices. So now we need to choose 4 vertices out of n vertices. So at most NC4, 4 vertices, subsets of subsets and 4C2. So out of this 4, 2 triangles have common edges. So ways to partition the 4 vertices into 2 triangles. Because there are 4 vertices and we have 2 triangles, we need to participate and with the common edges. So what one common edge is there with common edge. And what will be the probability being present all these 5 edges? Yes, tell me. Probability of all 5 edges in 2 triangles being present is, tell me, what is the probability of having one edges? D by n. So there are 5 edges. So what will be the probability?
D by 5.
D by 5. D by 5. The probability of having one edge is D by n. The second edge is also D by n. Third edge is also D by n. Fourth edge is also D by n. Fifth edge is also D by n. So all this 5 edges are present. Then what will be the probability?
5 D by
What 5 D by n?
D by n to the power 5.
D by n power 5. So it is D by n raised to 5. Then what will be the expectation of a triangle that is ijk delta ijk into summation I dash j dash k dash delta I dash j dash k dash is equal to how much? if it is belongs to S2 now. Now, not all, but it is belongs to S2. Then what will be this? It is NC4 into this d by n raised to 5. But NC4 we have, it is dn into n minus 1 into n minus 2 into n minus 3 into upon 4 factorial. What is 4 factorial? 24 d raised to 5 by n raised to 5. So this I can say it is written as 1 minus 1 by n, 1 minus 2 by n, this will be 1 minus 3 by n upon 24 into d raised to 5. 1n is cancelled out and 3n is adjusted, so 1n is left here. And this quantity is less than 1. This quantity is less than 1. So I can say this is equivalent to order d raised to 5 by n. So there are very few triangles in the graph with the probability of two triangles have sharing extremely unlike. That means this will tends to 0. So means that if n tends to infinity, this will tends to 0. So this type of situation is occurring in the graph is very less. So in S2 situation we'll have now S3, case number 3. Let S3 be the set of I, J, K and I dash, Z dash, K dash are same. Where I dash, that means the case number this thing. Then what will be the probability in this case? Can somebody tell me? So what is the expectation of summation ijk delta ijk into summation delta ijk? So what is the expected? And both this triangle is the actually same triangles. Okay, then what will be the probability? We have already discussed that. That means having one edge is probability is d by n, another edge is d by n, third edge is d by n. Choosing 3 edges out of n edges will be NC3. So what will be the probability? It is NC3 into d by n raised to 3. And this will gives me n into n minus 1, n minus 2 upon 6 into d by n cube. So I can say this is equivalent to write down d cube by 6 because n tends to infinity, this will goes to 1. So that's why this is d cube by 6. So finally, what we can have in this is actually not for all, this is for S3. So what we get finally, we get for expectation of this summation ijk delta ijk summation I dash z dash k dash delta ijk I dash z dash k dash is equal to the expectation of summation of S1 I dash z dash k dash plus expectation of summation of S2. That means we need to sum up all these three cases. The whole will be divide into these three cases and it will sum up to this. So this will be the less than or equal to. What we got for the first case, it is less than or equal to expectation x square. So that's why it is e of x square. In the second case, we have it is the big O of d cube by n. That is big O of d cube d raised to 5 by n. Plus, in the third case, we have it is d cube by 6. So it is d cube by 6. So this is the situation we have. And we know that on this side, it is nothing but the e of x square. So therefore, we have this. So if I take this quantity on the other side, that means if I subtract e of x square both sides, both this side of this inequality, we'll have it is e of x square minus e of x whole square is less than or equal to. You just observe that it is big O of d cube d raised to 5 by 6 plus d cube by 6 by n. And this side is nothing but the variance of x. That is less than or equal to big O of d raised to 5 by n plus d cube by 6. So this is the situation we got. And from this, the probability of the triangle is equal to 0 is less than or equal to is probability of mod of x minus e of x is greater than or equal to expectation of x. And we use the Chebyshev inequality here. So let us recall what is the Chebyshev inequality, which we have did in our high dimensional data. So the Chebyshev inequality tells you this, that probability of mod of x minus e of x greater than or equal to c is less than or equal to variance of x upon c square. Here, if you compare with this situation, then in place of c we have expectation of x. So therefore, by Chebyshev inequality, the probability of x is equal to 0 is equal to is less than or equal to, we know that it is probability of mod of e of x greater than or equal to expectation of x is less than or equal to variance of x upon e is square x, that is the variance of x upon c square. C square is expectation of x. We already calculated what is the variance of x. The variance of x is we have is this, that is d o of d raised to 5 by n plus d cube by 6 upon the expectation is also we have calculated is d cube by 6 and its square. So that's why this is less than or equal to, if I divide this quantity by this one, then it will left with 6 by d cube and plus this is 36 by d cube d raised to 6 big O of d raised to 5 by n. Okay, and you can just observe that So what I did is just doing this divided by this and this divided by this, and it leads to this. If n tends to infinitive, what will happen? This quantity will tends to 0 as n tends to infinity. Okay. So if n is goes to infinitive, that means n is very large, then the probability being a zero triangle is less than or equal to 6 by d cube. And for the value, if I can take this value of d, it is bigger than cube root of 6, then the probability is less than 1. So that means what I'm saying is, for if I choose my value of d which is greater than cube root of 6, a cube root of 6 is approximately 1.8. So if I my value of d, that means this value of d, if I take choose bigger than 1.8, then the probability of x is equal to 0. That means number of triangle is 0 is less than 1. And what we can conclude from this, in GNT graph model where P is d by n, has a triangle with 0 probability, non-zero probability. And for the d is less than this value, that is number of is this, it is very close to 0. This there are simply no triangle, no enough triangle, or sorry, there are no enough edges in the graph for there to be a triangle. So that is the conclusion we can make out of this. That if I have our value of d, it is bigger than 1.8, that means here this value will be less than 1, and this will obviously this will tends to 0 as n tends to infinity. If it is less than 1, if I can take this value is less than 1, then there will be very close to 0. There is no enough edges, so it will form a triangle. So that is the conclusion we make if a triangle, the existence of triangle in GNT graph model where P is d by n, it has a triangle or not. This is the scenario you can have. You may do the programming for this also. That means you start increasing the value of n, and you can just see at what the probability you will have, there is appearance of first triangle. So in iGraph, there is a command to check whether the graph contains a triangle. Okay, and using that you can build some program or do the programming for that. That if you increase the or decrease the value or increase the value of n, then you will have when you will have the existence of first triangle. So that's it for today. So that is the existence of triangle. If you have any question, you can ask.